take the test tomorrow? Raise your hands. Thank you, Mike. First thing first, my tests are not that hard. Chemistry is a hard subject, but my tests, like Chemistry B, there are 2 hard tests. That is definitely true. Chemistry A, there's 1, but this is not one of them. I took yesterday off, hung out with Derek most of the day, and we went through every test, not every question, but I just said, hey, answer a few of these. And he missed 1 question without any review and without really paying any attention. So they are not that bad. We will go over every single part of it. So I described this the first or second day, but let me describe it one more time. The way my tests work is you take an individual quiz on all of these subjects. All right? It's competency based. So chemistry, or the safety, I mean, if you get 4 out of 5 of them right, you get 100%. Now, the safety is really, really simple. You better get 4 out of 5 or you lack common sense. If you get 3 out of 5, you get 0%. And that's rough. But you can come in the next day and retake this safety test as many times as you need until you can demonstrate proficiency. As soon as you move to 4 out of 5, you're back to 100%. Does that sort of make sense? Okay, the matching, I think it's 7 out of 10 you have to get perfect on the matching. The accuracy and precision, I think it's 4 out of 5 again. Densities, probably 4 out of 5. Actually, there's 6. So I didn't need to erase that. It's 4 out of 6. These, I don't remember, but it's around 70, 75%. Go ahead. You can sort of ignore these points. This is 1 matching question. So it's all 10 of them, but like you match that to that, and that one to that one, and that one to that one. Does that make sense? Yeah. So it's just, these don't matter. Because even some of these will have 2 parts to the same 1-point question. Experimental design box, this one's just like that, where it's a matching question. Percent error, yada, yada, yada. So you can get, if you average 80% on everything, you'll get 100% on the exam. Even a little bit lower than that. So most kids will get an A on this test. Now, I'm aware that some of you don't like science, don't like math, and don't like testing. And that's unfortunate, but we can get even the worst test takers through this class with a B, well, I don't know, even with an A. So let's go ahead and review. So this kind of, when I cut and pasted it, it came out ugly. This is from when the test was a written test. So there are 1, 2, 3, 4, 5 questions about safety right there. I'm not going to go over the answers, but you take a minute, read through those and see if you could answer those true or false. And then say, hey, lab partner, I got false, 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 false. What did you get? Hey, no, that's not the right answers, by the way. But read through them and see if you think you could answer these questions effectively. Okay, there's only one of these that kids typically get wrong. It is not the first one. It's the 4th one. I will warn you, that is a trick question. So just whatever. The first one, I mean, there's some kids that miss it, but you're in a school, you hardly have any rights. Like you think you do. Like someone will say, you can't wear that. And you're like, that's my constitutional rights. Sure, off of school property, you can do what you want, but we pretty much own you. So number one's usually not missed. Number four is. So anyway, those are pretty much your safety questions. Okay, then these are your accuracy and precision questions. There's two that you can practice and look through and say, hey, could I do this? Yes or no. So read those, see if you think it's A, B, C, or D for each one, and then talk to your partner. Say, this is what I got. Do we agree? Okay, please tell your partner what you think these are. Okay, so here we go. Tom, Andy, and Marie. Who says they're accurate? Raise your hand. Okay, who says they're precise? So most of you are saying both accurate and precise. All right, and does anyone say neither? Okay, I'll take it. They're pretty close, especially on a high school scale, right? They're within a tenth or so, and they're all together. Okay, number 8, you and your 3 friends shoot darts at a target. Now, on the exam, these are the same questions, but they're the answers. I reserve the right to have different numbers, okay? So don't just memorize that Tom and Andy or whatever. Tom and Andy were best friends in high school, by the way. You and your 3 friends shoot darts. Each person's dart lands in the bullseye. What term would you say here? Would you say C? Good. They're both accurate and they're hitting exactly the same target. Yeah, well, I have good friends at a dartboard at home. And I did actually get really good at darts over COVID. That was one thing I could do. All right. Then here are your matching terms. Without using the front of your lab book, will you try? See if what you know and what you don't. Because you have 24 hours until you have to do this on an exam. So flip it over, write it on the back or something, and see if you can answer those questions. It used to be on paper. That's why the matching terms went to letter I. Oh, we rock, turns out. That's 7 people participating. I appreciate those 7. If you got to memorize, that's great, but I'm pretty sure we're going to prove tomorrow that you don't. All right, so we have these terms. Hopefully you're getting better at them. Volume, we would look at that. That's the number of cubes. So who had B is the correct answer. All right, that's more people that participated, so that's good. I don't know why this isn't working very well. B, meter is the unit of length, so that's a G. Who had that? Raise your hands. Awesome job. Area, probably the number of squares. There's that. So that's H. Who's good with that one? All right, gram, that's the tricky one. It's the 4 degrees Celsius. Just find that and you will be fine. Okay, density. Well, let's see. Let's cross these out. B, G, H, F. So now we are at density. And I believe that is right here. The amount of mass in a given volume. Because D equals mass divided by volume. So mass in a volume, that would be density. We good with that one? Who had that right? Okay, good. Centimeters squared, that's the unit of area. Centimeters cubed, unit of volume. Matter, the amount of matter present in an object. A lot of kids will get these two backwards, and I don't think it's their brains. I just think they read them too fast. They saw one before the other and went for it. What did I do? Oh, I did see. I just read too fast. I didn't pay attention. So it's, thank you. C and then mass. What did we say? D. Good. See what happens when you read fast? Here's the good news. I would have had 8 out of 10. And what would that have meant? 100%. So we learned from me and probably from your past. Read careful, double check, and they should be not super hard. Thanks for correcting me. All right, so that's the matching. Then we have some measurement reading here. Will you practice these two? That's about as big as I can make them. On the exam, they're actual pictures of scales, rulers, and graduated cylinders. Some of you, 7 of you, took this quiz yesterday in class. Thank you for doing that. I noticed by the end, only 2 of you took all of them, and I don't remember. I know Thurgood did. I don't remember the other one. Sorry. But I did appreciate that you did those. If you take those practice tests, you'll see the same test questions tomorrow. They're 95% the exact same because they access the same question banks. So do them. On my prep hour, I'm going to add more of these because there's only 3. They're the exact same 3 on the practice quizzes over and over. So I do need to add 1 or 2 more to that. Okay, try those real quick. These are both rulers, so they're centimeters, but they are different because they have different numbers of lines in between. So try them, write them down, check with your lab partner. Take about a minute and a half to do that. All right. So there is some variation here of what you think the right answer, but to be correct, it needs to be 7 point and then 1 number after the digit or after the decimal. And it could be, I don't know, like a 3. You could put a 1, 2, 3, 4, 5, 6, 7, 8, or 9. What it will be on the exam, it's multiple choice. It'll say 7.3, 7, 7.31, 7.35, or something like that. And you would go with the only one that had only 1 decimal after, 1 number, I keep saying that wrong, after the decimal. Okay, it's everything we know, and all we know is it's somewhere between 7 and 8, and then our guess. Okay, now this one, probably, especially on the screen, it's a little bit harder. We know it's between 2 and 3, so we know it's 2 point something, and then I don't know, I'm right here. It looks maybe a fraction short of the 3. So 2, 9. But you could get the same for 3, 0, 3, 1, 2, 8, whatever. It's a 2 and then 2 numbers after the decimal for that one. And that one will be just like this one. It'll be 2.3 is the right answer, 2.30, 2.300, or something like that. It will only give you one, so that the kind of gray area, that's gone. You only have one answer that's correct. So it's everything we know, and then an extra number that's a guess. Now, tomorrow you'll see some of these, and every time you read a measurement, how many numbers after the decimal place on these? 3. You don't have to do a ton of thinking. Find the one that has 3 numbers after the decimal for the scales. Yep. Okay. Thumbs up if we're all right with that part of the exam. Okay. Next is density. So let's do some practice here. It says a plastic block has the dimensions of 4,500 milliliters and a mass of 4,598 grams. What is the density? So we know density equals mass divided by volume. And by the way, tomorrow you cannot use your phones as a calculator. I have tons of calculators I can lend you, or bring your own, but you can't have your phones out during the test. All right, so if it gives me a volume and it gives me a mass, it's a pretty simple problem, right? I just plug it in. The mass is 4,598. And then the volume is 4,500. And I divide. Can someone type that in for me? Thank you, Miko. Oh no, it's because I'm over. Oh, it's probably because your screen protector is broken. Is that right? No. 4,598 divided by 4,500. There we go. She gets 1.02177778. All right, whatever. We get basically 1.02. We all right with that? Or 022, because it's multiple choice and the answer is right there. Now this has a secondary thing. So you click here, and then it says, using the densities from the table above, will the block float in water at 10 degrees Celsius? So we got to use some brains too. We come up here and we find 10. And the density of water is 0.9997. So if this is greater than that density, what does the block do? It's going to sink. You okay with that? Now, anytime in my class when there's a math question, it is set up that the computer automatically makes these variables. So don't memorize the answer, because every one of you in here will get different numbers right here. It's the same process though. It will be 10 too. This is not a variable. So these will be different. And some of you will get yes, it floats, because your variable's made a number less than 0.999. And some of you will get a variable more. You okay with that? Don't memorize answers, memorize processes. Yeah, you would click both of them. If you only click one, it will mark it all wrong. Okay. Do you want to do another one on this page? I'll just make them up. Raise your hand if you want another example. Okay, that is 0 hands. Okay. Sorry for carrying. All right, let's do something a little, let's make sure we're good with this Tom circle, because you will get some where you don't solve just straight for density. It was D, M, and V. And let me tell you, the mass, why did I write it that way? That's the weirdest thing, is 28 grams. Now let me say the density is 1.2 grams per milliliter. Will you tell me the volume? Practice this, because it's algebra that kills you, not chemistry. So find me what the volume is real quick. We're solving for volume with those two values. Yeah, it's 28 grams. That's about as good as my writing gets. And 1.2 grams per milliliter for the density. Excuse me. All right, so the process I go through to solve for V, you cover up V and you're left with mass divided by density. So I just take my mass, 28, and divide it by 1.2. And if Isaac's right, it was 23.33, right? So when you do the test tomorrow, please remember D, M's on top, V's on the bottom. If something's over something, you divide. If something's next to something, you multiply. Fair enough? Okay. That's just another density straight question. All right, this is about the kinetic theory of matter. Why don't you try these 3 questions? I hate this so bad. All right, this recording got paused and I don't remember where I was. I think I paused it here. So I'll just try and keep this review going. So we had just calculated these densities. So we had D equals M over V. And if I already did this, just fast forward it. So that's density is mass over volume. So I would take my mass, 4598, and divide it by 4500. And we get about 1.022, if I remember right. So we would say that part is correct. Now that's this part. Don't forget to answer both parts of the questions. It says, will it float at 10 degrees? So you come up and find 10 degrees, and the density is 0.9997. So since our density is greater than the density at 10 degrees, it would sink. So no would be the correct answer. Okay, hopefully that made sense. On your test, you'll have a different value here and here, but overall, that's what you would get. Okay. Then we reviewed the Tom circle. So please remember the Tom circle, you take your equation, whatever's on top when you've written it up is D equals M over V. You put the M on the top, the D and the V here, and then to solve. So if I gave you a mass was equal to 50 grams, and I gave you a density equal to 2.5 grams per milliliter, then I would ask, like, what's the volume? So to solve for volume, I would cover up the thing I wanted, so V, and then I'd be left with mass over density. So I would take 50 and divide it by 2.5, and then I would get, let's see, 10? Is that what that is? No, 20, sorry, 20. And that would be my density. So whenever we use the Tom circle, we cover up the thing we want to solve for, and then the math is left. So if I want density, it's mass over volume. If I want volume, it's mass over density. If I solve for mass, it's density times volume. Okay, hopefully that clicks. There's homework problems to practice this as well. Okay, if you want, you can pause it and work through this question. We want to know the density of liquid A, but we did not review this in class, but you can get a practice if you feel like it. Then we talked about the kinetic theory. The kinetic theory of matter, we did that on page 7 or 8, I can't remember. But it had an application, and it was about how all particles are in constant motion, and they're really small. So we said if the temperature of something is cooling, All right, that means the particles are starting to move slower. That was in the demonstrations that we did. And this was just a straight up definition. The ability of a substance to penetrate into another substance. We did an example in notes, that was diffusion. And then the light shines through the window and you see dust particles bouncing around. Those dust particles are like the little big particles that are moved because of the collisions of the smaller air particles. And we called that Brownian motion. So make sure you review, because there's more questions in this. Make sure you review that. All right, so review that in your notes to make sure you're all set. Okay, next, another kinetic theory. It's about Jane. You can read that. And once again, it's just if the temperature is increasing, the particles are moving faster. And this question is not on there, but one similar to it is. All right, then we discussed a nice analogy I learned in high school. If we had to fill a container with sand and marbles, if we put the sand first, we're unable to fill it with all the marbles. They overflow. But if we put the marbles first and then add the sand, everything fits in just fine. And it was an analogy of like setting your priorities correctly. So the reason behind this is that these marbles are much larger, but there's empty space between each one of them that the sand can fill in. Now, in chemistry, when we mix two things together, oftentimes the density will go up, but the volume stays the same. And that's because the smaller particles are acting like sand and the large particles are acting like marbles, and the small particles just fill in the gaps. So there's a question tomorrow that talks about that. Mixing of two things and the volume stays the same, or the thickness, it really says. And that is because the empty space between the molecules. Okay, these are just there on page 9 or 10. Constants, control, dependent variable, independent variable, and trials. You can find those matching terms on the bottom of when we started the scientific method. So just review those. Percent error, the equation for percent error will be given to you on your exam. So you do not have to memorize it. You just need to know how to recognize you're observed and you're accepted. So your observed is what a student would measure. So they found their observed to be 117. The accepted is what the book tells you, and that is that it's 114. And then you just plug it in. Make sure you do your order of operations correctly. Subtract these two first, and then divide the answer by 114, and then multiply by 100. If you do it out of order, sometimes you get drastically wrong answers. So once again, the equation's given to you. You just find the observed, that's first, the accepted, subtract it, whatever. If you get, this will be a positive number, probably like around, I don't know, 2.8% or something like that. Sometimes you get a negative though, and if the answer is negative, make sure to include that. Okay, this one is not, but if you get a negative, make sure to include it. Okay, then, this is the last thing, and it's an experimental design box you have to do on the exam. You will write it out on a piece of paper and turn it in, and it's this exact same one. So I'll just leave that for you to review and look through, and hopefully you're comfortable with that. If you need more help on that and you're online, quarantined right now, send me an email. And maybe we can meet on Zoom face-to-face and discuss it. So anyway, I hope this video made sense. I hope that I remembered where I paused it, and hopefully everything worked out all right.